This is Advanced Math Notes 2.6. The title is Solving Radical Equations Continued. Just a heads up while you're writing that title down, they're doing fire drills here today at Clovis West. So if you hear a loud, weird, buzzing fire drill-like noise, that is what's going on. It'll quickly pass and it may go on a few times, just giving you a heads up. Okay, solving radical equations continued. We did deal with this yesterday. Part 1, just a quick review of radicals that you've learned in the past. Can you add radicals? Question mark. For example, can you say the square root of 2 plus the square root of 3 equals the square root of 5? Is that correct? That is a no. No. They do not equal each other. Even if they were both square roots, like that's a square root, that's a square root, if the bases or the insides are not the same, you're not allowed to add them. All right. And if they were, if it was like root 3 plus root 3, then that would be 2 root 3. You still would not add the numbers on the inside. Okay, can you multiply radicals? For example, can you do root 5 times root 3 and call that root 6? Yes, yes you can. Now they have to both be the same index, for example, square root and square root, or cube root and cube root. You can't work them out if they were not the same. All right, and the last piece, can you, or are you allowed to divide radicals? Is it mathematically correct to say the square root of 27 divided by the square root of 3? Can you rewrite it like this and call it the square root of 9? Is it mathematically correct? You don't even have to rewrite it. Is it okay to straight divide 27 divided by 3? Yes, yes you can. All right, part 2, examples. You'll see why we did that quick review in just a little bit. Solve number 1, the square root of x plus 4 times the square root of x plus 11 equals 12. Okay, so I have two radicals that are being multiplied, and up here I asked, can you multiply radicals? And you guys said yes, or I'm hoping you said yes. Yes, we're allowed to multiply. So I can rewrite it like this with one radical, x plus 4 times x plus 11 equals 12. And now we can do the steps that we had the other day, where the step 1 was to isolate the radical, which it already is. Step 2 was to undo the radical, and we do that by squaring both sides. So I'm going to do two things at one time. I'm going to square, and I'm going to FOIL the inside. Squaring, they undo, the radical and the exponent undo each other. 12 squared is 144, and I'm going to FOIL that. X squared plus 15x plus 44 equals 144. Excuse me. And now we can see that we're ready to get equal to 0 so that we can factor and solve. I cannot factor and solve the way it is right now because it has to equal 0. The whole reason we do factor and solve is because we use the zero product property, which means it has to equal 0. X squared plus 15x, take away 100 equals 0. You can hit pause and factor on your own. Plus 20 minus 5, that gives me negative 100. 20x and negative 5x is positive 15x. I then go ahead and solve. X equals -20 and +5. And don't forget the last step that people always tend to forget is the check step. And I told you guys then on notes the other day that this is not a matter of I'm so smart, I never make a mistake, I don't have to check. It's not that case. You could have done everything correctly, but there's extraneous solutions, so you have to check. The question kids always ask is, how do we know which ones to check on the test? You want to check the ones that have square roots in the original problem like this. When there's a square root in the original problem, after you're done solving, you want to go back and check. The other ones that you check, that you compare, you're not really plugging in, are the ones that have extraneous solutions when you are solving. And I'll show you what I'm talking about if I can find the notes. Okay, here's one. Something like this. This is another one where you don't necessarily check by plugging in, but you check to your restriction. Your restriction is n equals 1. You do all your work. You end up with two answers, one of them being a restriction, so you cross it out, and 3 is your only solution. 3 is what you would write down. So on this one, you're not necessarily checking by plugging it in. You can, but it's not necessary. What you're checking it to is your restriction. So that's where extraneous solutions are going to happen here. On this one, you do actually have to check by plugging back in to the original problem. All right, so we're going to do that now. Square root of -20 plus 4 times the square root of -20 plus 11 equals 12. -20 plus 4 is -16 times the square root of -20 plus 11 is -9. Square root of -16 is 4i and 3i, and 4 times 3 is 12, but I times I is I squared. If you remember from last year that I squared is -1, so -12 does not equal +12, so that one did not work. What number was that? That was the 20. The 20 is extraneous. That doesn't mean the 5 works. We still have to check. Now, if you didn't use the i's and you just said, oh, I can't take the square root of a negative, it's not going to work, that is perfectly fine. I just showed you with the i's because some kids will say, well, I can take the square root. Yes, but even if you use the imaginary numbers, you still end up with a negative answer, and -12 does not equal +12. You could have stopped right there and said, oh, not going to happen, not going to work, that's never going to equal 12. Done with that checking. All right, next one. 5 plus 4 is 9 times the square root of 5 plus 11 is 16 equals 12. Square root of 9 is 3. Square root of 16 is 4. And indeed, 3 times 4 is 12. All is good. Your only solution then is 5, not the -20. That was an extraneous solution. Okay, we are moving on. Number 2. Number 2 is a test question, again, one that kids tend to struggle with. So you want to make sure you make time to go back and look over this one. Okay, square root like this, and then inside there's another square root like this, square root of x, and then a +3. So I know that looks wonky, but we will have to get used to it. Equals the square root of x plus 1. Okay. Step 1 was isolate the radical. Because there are multiple radicals, you're going to isolate the bigger one. And the bigger one's already isolated. It's already by itself. Everything's already moved over. So we're ready for step 2, which is undo the radical. And we're going to do that by squaring both sides. When we square the left-hand side, right here, those undo each other, but you're left with the inside radical. That inside radical does not cross out with that squared. Do you guys see that? Again, this squared does not cross out the inside radical, only the outer one. So the inside radical is left. Square root of x plus 3 equals, you cannot distribute. Please do not make that mistake on the test. And again, I do check your work. Okay, square root of x plus 3 stays, equals root x times root x is simply x, plus root x times 1 is root x, plus 1 times root x is root x, plus 1 times 1 is 1. Okay, now on the right hand side I still have like terms. Can you guys see that here? X plus 2 root x plus 1 equals the square root of x plus 3. Now, you look at the problem. We did step 1, we isolated the radical, it was already done for us. We did step 2 by undoing the radical, squaring both sides. We're trying to solve, but we notice there's still radicals. And if you remember from yesterday's lesson, if there's still radicals, you have to go back to step 1, which was isolate the radical. I have radicals on both sides. I want to get them to the same side. How you move it doesn't matter. You can subtract the 2 root x this way, or you can subtract the 1 root x that way. I'm going to subtract this way only because I'd rather not deal with negatives. All right, so root x, take away root x, it's gone. And that leaves me with 3 equals x, 2, there's a 1 there. 2 take away 1 is 1 root x, and then the plus 1. Do you guys see how that worked? X stayed x, 1 stayed 1, 2 take away 1 is 1, 1 root x. Okay, we want to get this root x by itself, so I'm going to subtract the 1, subtract the 1. I'm also going to subtract the x, gone, and gone. How you write this is up to you. You can put negative x plus 2 or 2 minus x. I'm going to put it as 2 minus x, excuse me, equals root x is what I'm left with. You can write as 1 root x if you choose to. I'm going to leave it as root x. Now I've isolated. I'm ready to undo by squaring both sides. Squaring both sides, remembering to FOIL the left-hand side. 2 minus x times 2 minus x equals simply x. 4 minus 4x plus x squared. 4, negative 2x is negative 4x plus x squared equals x, and it's just x because the squared and the square root undid each other. And now we're ready to get over to one side so we can factor and solve. So we subtract the x from its like term, and as I subtract the x, I'm also going to regroup. Gone. Positive x squared is coming out to the front, negative 5x, and then plus 4 equals 0. Okay, and now we're ready to factor and solve. X and x, minus 4 minus 1, giving me x equals 4 and positive 1. Do not forget, you have to check. Forgetting to check can hurt you on the test and you lose valuable points. Don't forget, when you're checking, you plug it into the original problem before you move things around, before you square rooted or squared, before you did anything. Okay, the first one I'm going to check is x equals 4. No reason other than it's the first number I have. Okay, so I'm taking x equals 4 and I'm going to plug it into the original. So I have the square root of 4 plus 3 with the big square root outside equals the square root of 4 plus 1. Okay, the square root of 4 is 2. 2 plus 3 equals the square root of 4 is 2 plus 1. 2 plus 3 is 5, and the square root of 5 does not equal 3. So 4 is an extraneous solution. I'm going to move it really quick and just simply cross out the 4 so I don't forget to later. And now I'm going to come back and I'm going to check 1. X equals 1. 4 didn't work. Okay, square root of 1 plus 3 inside the big square root equals the square root of 1 plus 1. Square root of 1 is 1. 1 plus 3 is 4. Square root of 4 is 2. Over on the right side, square root of 1 is 1 plus 1. 1 plus 1 is 2, and 2 indeed equals 2. Therefore, 1 is the only solution. X equals 1. So we've seen these extraneous solutions a lot in this lesson. So now they're really coming up where if you're not checking, it is going to hurt you. Okay, we have one more problem to do, and then this lesson is done. And this last one is another test question. And this one I think is probably the most missed. I know I've given you a few where I said kids struggle with. This particular one, kids mess up every year. Square root of x plus 2 fourth root of x equals 15. And I'm going to put test over here. Come back and study this one. I'll put extra stars because people always forget, and then test day comes and they're like, Mrs. Torres, I've never seen one like this. I don't know what this is. I don't know what to do. And then they freak out. Again, you don't want to lose little points here and there by messing up on all these little things that I keep reminding you about. Okay, first off, we see this and it looks nothing like the problems that we just spent all the last 15 minutes doing. We were adding radicals and multiplying radicals, but do you see that this is a square root and this is a fourth root? What in the heck do I do when I'm trying to add two different radicals, or radicals with two different indexes? This is a 2 square root, this is a 4 a fourth root. I can tell you right now you can't do it. You cannot add these. You can't do anything with them because that's a fourth root and that's a square root. Okay, so I showed this to you because it comes up on this particular lesson on homework. It shows up here because there's radicals, just like all the last, 2-3 problems that we've been working on. All the radicals, they're all there. But this is a different problem in disguise. This is like lesson 3-ish, 2.3. If you look back at 2.3 notes, you will see some that didn't look like this, but these are in disguise, and I will show you what I am talking about. What you're going to do for each one is rewrite. You are going to rewrite it like so. X to the 1/2 plus 2x to the 1/4, I'm going to subtract that over, minus 15 equals 0. Now I'm hoping when you look at that, you're like, oh, I do remember doing those problems. I'm going to show it to you really quick. It's something like these here. Remember when we did this on lesson, it was either 2-3 or 2-4, where we did them like this. And then we always took, oh, sorry, I'm not in screen, like this right here. And then we factored, double bubbled, and all was good. Let me show you another one that was on lesson 2-3. Here it is right here. Here's lesson 2-3, w to the 1/2. This is w to the 1/4. I'm going to continue. You can see it here.